Assalamu alaikum everyone. I hope you are fine and you enjoyed the last lecture and maybe you have already done the homework. So today lecture I will start from the previous lecture if someone has not done the homework. So actually last time I asked one question for homework that was about this show that W is not a subspace of V where consists of all matrices with zero determinant. For subspace, there were three conditions we have to prove. So first condition was 0 should be in W. Now if you write say because now we are talking about matrices. So previous example all we are talking about r power 3. So now we are talking about matrices. So you can take either 2 by 2 matrix, 3 by 3 matrix, it's up to you. So the easiest way is to solve, we can take 2 by 2 matrix. So if we write 0, so it will be 0 matrix, so 0, 0, 0, 0. Now if you take determinant of this 0 matrix, we are denoting this matrix with 0, so that is why I am writing determinant of 0. So if you take determinant of this, you know how to take determinant. You multiply 0 with 0, minus 0 with 0, so the answer is 0. So it means it is 0 because what is the question? We show that W is not a subspace of V where W consists of all matrices with 0 determinant. So determinant is 0, so it means this satisfies the condition. Now the for second condition, there was second condition. If we take two vector u and v, and if I add u plus v again, it should be in W. So here instead of writing u and v, I am writing a and b. You can write u and v, there is no problem. So for example, if I suppose let a is equal to 1 0 0, this belongs to W. Why I have taken this 1 0 0? Can I take some other? Yes, I can take some other also. Just like if I write here 2 0 0 0, I can write some other. So what matrix you have to write here? If I take determinant of this, so the answer must be 0. It should belongs to W. When I say belongs to W, it means the determinant of this must be equal to 0. So if I write determinant of this, 1 multiply 0 minus 0 multiply 0. So this will be 1 multiply 0, so 0, and 0 multiply 0 with 0. So it means determinant is 0. Similarly, I can take another B which also belongs to W. Why belongs to W? Because determinant of B is also 0, because 0 multiply 1 0 minus 0 multiply 0 0. So it means it also B also belongs to W. So because determinant of 0, determinant of 0. Now if I find A plus B, and if A plus B determinant is also 0, then this condition will satisfy. And if A plus B determinant is not equal to 0, then it means this condition will fail. So now if we find A plus B, so A plus B, when you add this, so 1 plus 0, so it will be 1, 0 plus 0, it will be 0, 0 plus 0 is 0, 0 plus 1, it is 1. Now if you find determinant of this, determinant of A plus B, so 1 multiply 1, so 1, and minus 0 multiply 0, so 0, so determinant is 1, so it is not equal to 0. It means A plus B does not belongs to W. So therefore W is not a subspace of V. So there is no need to check the third condition. Third condition was if I multiply K with U, and it again should belongs to W. So there is no need to check the third condition. When one of the three condition will fail, so you will stop there. So this was your homework. If you have done, so that's great. But if you have not done, so you can find the solution here. But try to solve yourself, and then you can ask questions during our Moodle class. So I prefer if you can ask as many questions during our Moodle class online. Our classes are Sunday, Tuesday, Thursday from 9 to 9:50. So at that time you can ask even more questions. Okay, so that was from the previous lecture, and now I will start my new topic. So my new topic is null space. So just like previous we studied subspace, now is null space. So what is the definition of null space? The definition is the null space of M cross N matrix A, written as null A, N-U-L-A, null A, is the set of all solutions to the homogeneous equation Ax is equal to 0. So it means if I want to prove something it is a null space or not, what I will do, I will multiply a with x, and if my answer is 0, so then it means it will be in null space. So I will write null a equal to x such that x is in Rn and ax is equal to 0. Actually, the main condition to prove whether some vector is in null a or not, so what we will do, we multiply a with x, and then if it is 0, then it is in null a. If it is not equal to 0, then it is not null a. So I think definition is clear, but still if you find difficult when we'll solve example, it will be even more clear. Now next is column space of a matrix. So what is column space of a matrix? The column space of m cross n matrix. In previous definition it was also m cross m. M cross n mean m number of rows and number of columns. So that is why we write m cross n. Matrix A written as column of A is the set of all linear combinations of the columns of A. If we have A matrix A1, A2, An element, then column of A will be equal to spanning set of A1, A2, An. Note that column of A can be equal to B such that B is equal to Ax for some x in Rn. Now maybe this definition is a little difficult for you people to understand, but what I did, I make your life more easy by writing these two notes. So if you focus on these note 1 and note 2, then to understand null space and column space, it's very easy. So if you want to check it is a vector v is in null A, what you have to do, you have to prove if a v is equal to 0. So a will be matrix, v will be vector, and if I want to prove vector v is in null A, what I will do, I will multiply the matrix A with the vector v, and if I get the answer 0, it means vector v is in null A. Very simple. And if I want to prove a vector v is in column A, then what I will do, if ax is equal to v is consistent. Now what is consistent? Consistent mean it has a one solution or infinitely many solution. So it means if ax is equal to v have a solution, then it is in column A, and if it has not a solution, then it is not in column A. Simple. You don't need to find the solution, only you will check whether it has a solution or it has not a solution. If it has a solution, then it is in column A, and if it has not a solution, then it is not in column A. Very simple. So, and you know how to find solution of ax is equal to v. It is same like ax is equal to b instead of b. Now we are writing here v. Otherwise everything is same. So if we want to prove it is in column A, so what you will do, you will find solution of ax is equal to v. A will be given, v will be given. We can find x values, x1, x2, x3, and then if x has the solution, it means maybe you have a unique solution or you can have infinite many solution, then it means it is in column A, and if it will not have a solution, then it is not in column A. Okay, I think now the definitions are clear. Now we will solve some example and then it will be even more clear, inshallah. Now we move to example, first example. First example is let x1 minus 3x2 minus 2x3 equal to 0, minus 5x1 plus 9x2 plus 9 plus x3 equal to 0. That is ax is equal to 0 because whatever it is written, this is ax equal to 0, where a equal to, what is matrix here, A, if you want to write the matrix A, it will be 1 minus 3 minus 2 minus 5 9 1. So this is the matrix A, and let u is the vector which is 5 3 minus 2. And now we have to prove if u belongs to the null space of A or not. So that we want to check if u belongs to the null space of A or not. So what we will do, as I said in the beginning, the definition. So if you multiply A with u, and if your answer is 0, then it is in null A. Now we will do the same thing. You multiply A with u, So you know how to multiply matrices. So you multiply 1 with 5 plus minus 3 with 3 plus minus 2 with minus 2. So you will get 5 minus 4 plus 4. And similarly, you will multiply the second row. Minus 5 multiply 5, so minus 25 plus 9 into 3 is 27 plus 1 into minus 2 is minus 2. And now if you simplify this, so 5 plus 4 9, 9 minus 9 is 0, and minus 25 minus 2 minus 27 plus 27 it is 0. So therefore AU is equal to 0. 0 means this 0 matrix, so it means AU is equal to 0. So therefore U is in null A. If for example it is AU is not equal to 0, maybe here you get some number, maybe 2, 3 and 1 is 0, 1 is not 0, so then it is not in null A. So very simple. Similarly, second example is determine if W5 minus 3 2 is in null A, where A is given this matrix. Again, you will do the same thing. You multiply A with W, and you know how to multiply matrix A with this matrix. So you multiply this all, and you will see you get 0, 0, 0. So therefore, W is in null A. Very simple. I hope it is clear. And now we can solve another example where we will check whether it is also in column A or not. So now let A is equal to this matrix, and let U is this 3 minus 2 minus 1 0, and V is 3 minus 1 3. Now we have to check if U is in null A or not, and if V is in column A or not. Now both questions are asked in the same question. So U is this vector, V is this vector, and now we want to check whether U is in null A. For U we want to check null, and for V we want to check column. So for null, you know the solution. If we multiply A with U, A and multiply with U, and you know how to multiply. 2 multiply 3, so minus 6. 6, 4 multiply minus 2 minus 8, then minus 2 multiply minus 1, so plus 2, and 1 multiply 0 0. Similarly, you can multiply second row with this column and third row with this column. So you can get this. And now if you add this, 6 plus 2 is 8, 8 minus 8 is 0, and 10 minus 6 is 4, 4 minus 7 is minus 3, and then 8 plus 9 is 17, 17 minus 14 is 3. So you can see now we get 0 minus 3, 3, and it is not equal to 0 0 0. So therefore U is not in null A. In last two example you saw we get 0 0, but here you can see here we get 1 0, but other two are not 0. So overall this mat is not equal to 0 0 0. So therefore U is not in null A. Now to check whether V is in column A or not, since we know what was the definition was AX is equal to V. And if this AX is equal to V has a solution, then it is in column A. And if AX is equal to V is not have not a solution, then it is not in column A. Now you know very well from the previous lecture how to find a solution. So what we will do, we will write the augmented matrix AB. You know, in previous lectures we write AB as augmented matrix. So your augmented matrix A is, you know, it is 2 4 minus 2 1 minus 2 minus 5 7 3 3 7 minus 8 6. So you have written this, and then here we have written the vector V. V is your vector V is 3 minus 1 3, because we want to check if V is in column A or not. So you know this is the augmented matrix. It is same like we have already done in many time in our previous lectures. So now what we want to do, we want to find solution of this. So we will do by row reduction method. So for row reduction, what you will do here, first you can see it is non-zero, and now we want to make below this and this 0. So for this they are not same, so we want to make this all these three same. So what I can do, I can multiply this with 3, and this with 3, and this with 2, and then these will become same. Now it means I will multiply row 1 with 3, I multiply row 2 with 3, and I multiply row 3 with 2. So if I multiply row 1 with 3, so you will get 3 2s are 6, 3 4s are 12, 3 into minus 2 is minus 6, 3 into 1 is 3, 3 into 3 is 9. Similarly, I can multiply row 2 with with 3, so it will be 3 into minus 2 minus 6, 3 into minus 5 is minus 15, 3 into 7 is 21, 3 into 3 is 9, and 3 into minus 1 is minus 3. And the third row we will multiply with 2. So 2 multiplied with 3 is 6, 2 multiplied 7 is 14, 2 multiplied minus 8 is minus 16, and 2 multiplied 6 is 12, and 2 multiplied 3 is 6. Now you can see here 6, 6, 6. So now the row 1, row 2 and row 1 I can add, and row 3 I can subtract from row 1, and then I can make this and this 0. So now I think it is very simple, very clear, and just wait for 1 minute. I think one. I'm just wait 1 minute. I'm coming. Okay, sorry for disturbance. Okay, now so now you can see we get if row 2 plus row 1, so we get 0. Row 3 minus row 1, we get also 0 here. So we get here minus 3, minus 15, minus 3, 15, 12, 6. And you know this all how we get this. Now you can see here is minus 3, here is 2. And we want to make this both same, and we want to make this 0. Now I multiply this with row 2 with 2 and row 3 with 3. So then this will become minus 6, minus 6, 6. So I multiply row 2 with 2, row 3 with 3. So you can see this if I multiply with 2, so 6, 30, 24 and 12. And similarly if I multiply 3, so 6, minus 30, 27 and minus 9. Now I can add row 3 in row 2. So I will get 6 plus 6 minus 6, 0. So minus 30 plus 30, 0. 27 plus 24, 51. And minus 9 plus 12, it is 3. So now you can see from there it is very clear. It is clear that the equation AXV is consistent. That is, it has a solution. You can see from here that from the third row, 51, say if I say this x1, x2, x3, x4, so 51 x4 equal to 3. So I can find the value of x4, which will be 3 over 51. And similarly, I can find other values. So it means I will have a solution, whether a unique solution or infinite many solution, I will have a solution. So therefore, it is consistent and it has a solution. So therefore, V is in column A. So when V is not in column A, when it will not have a solution. It means, for example, if instead of 51, here I get also 0 and here 3. If this 0, this 0, this 0, this 0, so then it means it has not a solution. If it has not a solution, then it is not in column A. Now I think now it is clear. Now time is for homework. So let A is this matrix minus 6, 12, minus 3, 6, and W is 2, 1. Now you have to check if W is in column A or W is in null A or not. Similarly, in another example for homework, let A is equal to minus 8, minus 2, minus 9, 4, 6, 4, 8, 4, 0, 4, and W is 2, 1, minus 2. Now again question is whether W is in column A and is W in null A. So very simple lecture. So please try to focus on this. Try to solve all the example what I solved here first, and then you can try these two. It will be very easy. Thank you very much for your attention, and I hope everyone understood the lecture. But still, if you find any difficulty, any problem in next Moodle lecture, online lecture, so you can ask question. I can explain over there, and have a good time and take care of yourself and your family. Assalamu alaikum.